Welcome to the second part of VCAA Math Method 2021 exam paper series. In this video, we will present exam paper 1, question 6 to 8. Statistically, these three questions were not answered well. Students struggled in using the probability table, identifying correct distribution parameters, and performing required integration accurately. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Welcome to this Math Method VCAA exam paper series. In this video, we will present you questions from 6 to 8 of exam 1 2021 paper. Let's start from question 6. As you can be seen from the criteria of this question, there are 4 types of donuts with a total number of 20, and among them, half of it are donuts with custard. 7 out of 10 are not glazed, but 1 out of 10 are glazed with custard. According to that, there are 3 parts in this question, and part A is to find the probability of a random chosen donut that is not glazed but with custard. Here we continue to describe part B of this question. If the total 20 donuts are randomly allocated to 2 boxes, namely box A and box B, each of them contains 10 donuts. One of them is chosen at random, and then a donut from the chosen box is also chosen at random. If here G is the number of glazed donuts in box A, the question is to find the probability in terms of G that the donut comes from box B, given that it is glazed. In part C, based on the fact that half of people who visiting the online shopping sites are under 25 years old, we know population proportion is 0.5. The question is, if 5 visitors are chosen at random, find the probability that 80% of them are under 25 years old. Now let's come back to solve question A. According to the given criteria, a Carnot map or probability table is drew to sort out the relations of 4 different types of donuts. Here C represents donuts with custard while G represents glazed donuts. The corresponding probabilities of 4 types of donuts are filled into the table accordingly as shown on the screen. Here we continue to solve part A of this question. As we know, a probability table is an alternative to a Venn diagram when illustrating a probability problem diagrammatically. As it can be seen, in the probability table, the entries give the probability of each of these types of chosen donuts. Some of them are given as displayed earlier, and some of them are calculated accordingly. So the probability of choosing a custard but not glazed donuts equals PR of C minus PR of G intercept C, which equals 2/5. As for part B of this question, since the number of glazed donuts in box A is G, then the number of glazed donuts in box B is 6 minus G, because the total number of glazed donuts are 6. Hence, the conditional probability of choosing box B given that the donut is glazed equals PR of G intercept B over PR of G, which is simplified to 6 minus G all over 6. Since we are not allowed to use normal approximation to answer part C of this question, the option left for us is to use binomial distribution. We listed the formula for binomial distribution, where P is the population proportion, which is 0.5, and n is the sample number, which is 5. Hence, the probability of the sample proportion is greater than or equal to 0.8 equals PR of 4 plus PR of 5, which can be written to 5C4 times 0.5 to the 4th times 1 minus 0.5, or in parentheses plus 5C5 times 0.5 to the 5th, which equals 3 over 16 after being simplified. Question 7 provides a probability density function f of x as shown on the screen. F of x equals k over x squared when x is in the closed interval from 1 to 2, and f of x equals 0 elsewhere. Part A of this question is to show that the constant k equals 2. Part B of this question is to find the expected value of the random variable x. Since we know f of x is the probability density function, the integral of k over x squared with respect to x valued from 1 to 2 equals 1. Hence, we proceed the integration and proved that the value of constant k equals 2. As for the expected value of the random variable x in part B of this question, according to the formula, e of x equals the integral of x f of x dx valued from 1 to 2, which equals 2 ln of x valued from 1 to 2. Hence, the expected value e of x equals 2 ln of 2. In question 8, it is given that the gradient of the function is square root of x plus 6 minus x over 2 minus 3 over 2. In addition, the graph of the function has a single stationary point at 3, 29 over 4. There are two parts in this question. Part A of this question is to find the rule of the function, and part B of this question is to determine the nature of the stationary point. Since dy by dx equals square root of x plus 6 minus x over 2 minus 3 over 2, y equals the integral of square root of x plus 6 minus x over 2 minus 3 over 2, or in parentheses dx, which equals 2 over 3 times x plus 6, or in parentheses to the 3 over 2 minus x squared over 4 minus 3x over 2 plus c. According to the given coordinates of the single stationary point, y of 3 equals 29 over 4. Hence, the constant c can be calculated, which is -4. Therefore, the rule of the function is that y equals 2 over 3 times x plus 6, or in parentheses to the 3 over 2, minus x squared over 4, minus 3x over 2, minus 4. As for part B of this question, in order to determine the nature of the stationary point, we can either look at the gradient value around the stationary point, or examine the value of the second order differentiation at the stationary point. Here we just do the second order differentiation and see if it is positive, negative, or 0. So since dy by dx equals square root of x plus 6 minus x over 2 minus 3 over 2, the second derivative of y with respect to x equals 1 over 2 times square root of x plus 6 minus 1 over 2. Based on the calculated result that the second derivative of y with respect to x at x equals 3 is less than 0, we may conclude the stationary point is a local maximum. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.